So here you are again to my channel and welcome to Exciting Play channel. So today I know some of you have known about the matrix operations and matrices, but you might be wondering how we can implement that in Python. So for that I have created a simple project for you to understand the basics and as well as learn about the matrices. So let's switch to a demo part. Before demo, let me just tell you about some project. So this is going to be a matrix calculator, and it allows user to perform the basic matrix operation or arithmetic, something like addition and subtraction between the matrix multiplication, and determinant calculation. And also, this is basically how this project is going to be implemented. Is basically all the metrics are going to be created in the lists, and all the operations are going to be implemented using the loops and functions. And the concept used here are like list, loop, Python condition statement, user input, and basic recursion for determinant calculation and input validation. Now, without wasting any more time, let me just show you the demo. So, if I want to add two matrices, I can simply put the choice one here, and it start asking us for some values like how many rows there should be in matrix. I say two. How many columns? I say again two. That means we have created 2 by 2 matrix. Now for some reason, let's say we have created something like this. They say, okay, matrix should have the same dimension for addition and subtraction. So that means there might be the same size. So again, repeating the same thing. Now it is asking for the elements of the matrices. Now the elements can be done by 1, 2, 3, 4, and 1, 2, 3, and 4. Basically, why I am entering these elements to basically see the output that okay, the output is actually correct or not. So that's why I am using such a simple example. So in the similar way, subtraction can be implemented. So with that, I conclude the demo. But we will basically see the feature one by one after doing some calculation, after seeing the function, and then we are going to implement that function here. So how is that? Yeah. So that's how we are going to do. So first, let us discuss about the basic function, that is taking an input matrix. So for that, we take two arguments. First is rows and columns, and you can say we print the statement like enter the elements of matrix rows by columns. Of course, that is what we are going to print, right? And then we are basically initializing the matrix here using for loops for the basically the rows, and then creating a empty list here row, then using a for loop j for the columns, and we are using this well, basically the value of the position of a matrix, basically ij element. And then what we are doing is we are appending these values one by one into the rows, and at last, after this number of columns actually exhausted, we just take the whole row and append it to the matrix. So in that way we create a input matrix here with the rows and columns, so which you have already seen here. As you can see, it asks for us some dimensions, this, and at last, so this is where this function start executing. It start executing at this sorry, it start executing at this line, enter the elements of matrix 2 by 2. Basically the 2 and 2 are the input for this function. So that's how it is working. Now uh, talking about the next thing. So as you can see, the next thing is displaying a matrix. So basically, why I am creating this function, to basically keep things clean here. That's why I am creating the separate functions. So as you can see, it says print matrix, and then using the for loop, basically two nested loop. Basically, first we are iterating through the rows of the matrix, then we are iterating through the basically the elements in the row and printing them one by one, and we substitute end by tab space, and that's how. And after putting the print statement, we basically going to the next line for the next rows. So that's how this display matrix works. Now to show you the example, to make it clear, so you can see that okay, now we have matrix here, as you can see, after like executing this whole thing, we get to print something like, okay, 2 4 2 2 2 4 2 4 and 6 8. So that is something that we have printed. Now we have 2 by 2 matrix actually, so I think there is some issue in this code which we will target later, but for now let's just see. As you can see, we have actually got the output 2468, and that is what we are seeing here. And let me just quickly see the output where it is showing us such kind of desired thing. Maybe that can be also be ignored here actually. So for now, let's ignore that. So talking about the adding the matrices, we take two inputs, basically the two different matrices here, and we are basically using the length of matrix to initialize the value for the rows and the length of the element of the matrix to basically initialize the number of columns in that matrix. So and that we create a result matrix, and in the result matrix we then create something like this row append, and then saying for j in range columns row append this. Basically we are adding the elements of two matrix, basically element wise addition, and then after performing this element wise addition, we basically appending the result to the result list, and that's how we are basically creating this addition feature. And in the similar way, we are basically just changing the sign here to negative, and the same thing can be implemented for subtraction. Now for seeing the subtraction, we can just execute this again, and right now I want to select option 2, say 2 2 2 2, and for the element I will say 1 2 3 4, 1 2 3 and 4. It should result in 0. As you can see, we got the 0 matrix here, and that means our code is working. Yeah, so we have actually seen the addition and the subtraction of matrices. Now talking about the multiplication. Now here things are a little bit tricky, but need not to, you can say, make yourself think like, oh, what is happening right now. So ignoring that fact, so first we are going to take two matrices input, of course. Then we create the rows and matrix size, basically taking the inputs such as R1, C1, R2, C2. R1 and C1 basically the rows and number of rows and columns of matrix A and B, and the similar rows and columns of matrix A, and R2 and C2 are the rows and columns of matrix B. Then we create a result, and how this result is created, let me tell you. Basically, this is a list comprehension. So I will tell you about this later, but for now, just think that we are creating a list of, basically, this is the list of something like this R1 zeros, and how should I tell you? Okay, let's say for a matrix of 2 by 2 size, 2 2 by 2 size matrix is going to look like 0 0 0 comma 0 and 0 comma 0. We are basically initializing 0 matrix of size 2 here, and then we are again looping through the whole thing. Basically the range, first we are looping through the rows and then columns, and of course then we are also looping through the columns of you can see the matrix second. And why is that, I will tell you, but as you can see, as you already know, the matrix multiplication goes by like we take the row of matrix 1 and a column of matrix 2 and perform the element wise multiplication, and then for a position, let's say 101, we add all these values and we get the resultant matrix of size I comma j, and here the matrix A size is I comma k and B size is k comma j. So these kind of things are what core mathematics include. So now let's start by implementing the matrix multiplication. So as you can see, I first choose the matrix multiplication, and then I input the size, let's say 2 by 2 matrix, and the 2 by 4 matrix. The resultant matrix should be of size 2 by 4, and which we are going to see. But before that, let me enter the elements. Let's say I want to start with 0, 2, 3, and again 0. Let's say this is the resultant matrix, sorry, the matrix A. And for the matrix B, we say like, okay, 0, 0, 2, 3, 4, 5, 0, 0, and 1. So when we do this, as you can see, after multiplication, we get this resultant matrix. And this resultant matrix can be simply interpreted by, so this is going to be your first row, 0 and 2, and this is going to be your first column, as you can see. So this 0 is going to be multiplied with this 0, and this basically is 0. This 2 is going to be multiplied with this 0 again, and then in the similar way we just multiply everything one by one, and we get our answer. So that's how it is actually calculating the result. So I hope everything is clear up until now, but if you have any confusion, I'm there. So after that we have to next see the, oh sorry, I just closed the terminal, which basically can stop the execution. And yes, the next part is determinant. Now that is the, you can say, the core part that I will recommend everyone to correctly view. So this is going to include some, you can say, recursion, which is the best algorithm for repeating for repetitive tasks. Now it says, okay, if the length of the matrix is n, and if the length of the matrix is 1, basically it only contains the single element, then return the element to us. And if the matrix size is 2, that means if the matrix size is 2 by 2, basically the determinant is only calculated on the square matrices. So that's why we first multiply the elements of the diagonals and the elements of the rest elements, and we subtract the diagonal element multiplication by the other element multiplication, and we get the determinant. And now the things got weirder if the size become greater than 2. Basically not weirder, I will say. That is how it is implemented. So first we initialize determinant to 0, because determinant is a unit number, not a matrix. So we use the loop like for p in range n. Basically n is the size of matrix. For the sake of, you say, okay, the size of matrix is 3 by 3, so the n becomes 3. So it is going to take the p from the range n and going to build a submatrix here. Why submatrix? That is also going to be get clear to you all, because it is something like I will show you. Then we use for I in range 1 comma n, then starting from 1 and goes to the n minus 1 and creating the row, and then creating the column, and then we are just simply stating the condition that, okay, don't take the pth element and append everything else into the submatrix. So here, after creating this submatrix, we are going to say, okay, determinant is going to be matrix of 0 comma p multiplied by determinant of submatrix, and this is going to be repeated until multiply. This is going to be like this. Basically, it is returning 1 if p is an even number, else it is going to return us negative. Basically, the odd number of, you can say, the size of odd number matrix is going to be negative determinant. So that's how we implement determinant. Now let me just quickly show you the determinant code. So okay, if I want to implement the determinant code, we have to enter the size of a square matrix. So let's say I want to calculate the 3 by 3 matrix determinant. It says okay, I enter the element 1. I say 1, then 2, then 3, then 4, then 5, then 6, then 1, then 2, then 4. So as you can see, we get the determinant of this 3 by 3 matrix, and that comes out to be -3. And how is that? We take the 1 comma 1 element basically, and we ignore the first row and the first columns, and after ignoring them, the rest that left with us is the submatrix. And we calculate the determinant for submatrix by simply going the diagonal element and that all. So that's how the determinant is calculated. And with this, we basically wrap up this project and wrapping, and we have actually done with our basic level projects. So meet you in the next video. And also the next part we are going to start is core programming. And the thing that I'm thinking of starting with is going to start with the error handling. So up until now, I hope everything is clear, but if you still have some doubts, I will address them. And how you can share them, you can either you can put them into the comments, and I will see them and make a separate video on them. So that's all from my side. Hope you like this project and all the projects that we have done up until now. So basically, we after this we got an collection of 12 projects, 12 beginner level project actually. So I believe that is more than enough for the beginner level. Then the next thing we are going to do is intermediate level. So that's all. And okay, everyone, meet you in the next video.